You ever wonder how Earth manages to survive? I mean, we've been floating around the sun for billions of years, and so far no signs of slowing down. But there are forces out there that could quite literally pull us off our orbit and send us hurtling through space never to return. So what keeps Earth in its rightful place? Hey, welcome to my channel, and today we're going to talk about sun currents, those invisible rivers of plasma that flow from our star and affect everything in the solar system, including Earth. All right, let's go. The sun is massive, like really big. It's almost 340,000 kilometers across. That's the size of over 109,000 American football fields lined up side by side. That's also an awful lot of mass. Our sun weighs about 1.989 x 10 circumflex 30 kilograms. For some real-world context, that's about 333,000 times heavier than Earth. Now, this much mass makes the sun pretty gravitationally dominant. Like if you brought that baby anywhere near Earth, we wouldn't be able to resist. We'd just get sucked into its colossal depths and be completely obliterated. In fact, anything that gets too close to the sun's event horizon never comes back. Not stars, planets, even light can't escape its gravitational pull. But here's the thing. The sun isn't just sitting still, it rotates. Okay, technically nothing in the universe is truly at rest because everything vibrates at the quantum level. But you know what I mean. The sun rotates on its axis roughly every 27 days. That's about 10 minutes longer than it takes for Earth to do the same. And when the sun rotates, it drags stuff along with it. Now, remember, the sun is made mostly of hydrogen. That means most of its parts are in plasma form, which is a super-hot ionized gas. This electrically charged plasma becomes a giant global dynamo. As it rotates, it generates a massive magnetic field that extends from the sun's core all the way out to Pluto and beyond. This magnetic field carries electric currents, and as these currents flow from the sun to the planets, they carry energy with them. These electrical currents are called solar currents. They're invisible rivers of plasma that flow from our star and affect everything in the solar system. And although the sun's magnetic field is invisible, we can actually observe these currents by looking at the sun's corona. The corona is the outermost layer of the sun's atmosphere, and it's so hot that it reaches 2 million degrees Fahrenheit. That's about 1 million degrees hotter than the surface of the sun. Because the corona is so hot, it emits ultraviolet light, which is invisible to the naked eye. But when the ultraviolet light hits the upper layers of Earth's atmosphere, it ionizes the gases there. These newly charged particles reflect radio waves, making the corona visible from Earth. And when we look up at the corona through special instruments, we can see these beautiful plasma flows. They look like giant swirls of light, and they're called solar prominences. These solar prominences actually play an important role in helping us understand our relationship with the sun. See, the sun's magnetic field has a crucial impact on life on Earth. Not only does it help protect us from cosmic radiation, it also drives our weather and climate systems. Every 11 years, the sun goes through a cycle of activity that scientists call a solar maximum. During a solar maximum, the sun's magnetic field flips and sunspots become more numerous and active. These sunspots have intense magnetic fields that twist and tangle with each other, creating a kind of magnetic tsunami. These magnetic avalanches release huge bursts of radiation and plasma called solar flares and coronal mass ejections. And when they erupt from the sun, they're aimed directly at Earth. In 2012, one of these coronal mass ejections hit Earth's atmosphere and triggered a geomagnetic storm. Geomagnetic storms happen when charged particles from the sun interact with Earth's magnetic field and induce electric currents in the crust. These storms can mess with communications, navigation systems, and power grids. If one hit Earth today, we'd likely face widespread blackouts and serious damage to our infrastructure. But these magnetic avalanches aren't always this destructive. Sometimes they can trigger beautiful auroras. So you might be wondering, how do we keep track of all this? How do we keep watch over our sun and prepare for incoming plasma? Well, it helps that we have some pretty clever satellites orbiting the globe. One of the most helpful is NASA's Solar Dynamics Observatory. The observatory launches from Cape Canaveral, Florida, and orbits the sun. This means that it's always watching the sun from the same distance away, and that makes it easier to spot features like solar flares and sunspots. The Solar Dynamics Observatory has been watching our sun since February 2010, so it's been documenting these cycles of activity for over a decade. Okay, now we're ready to go back to those currents. Remember how I said that the sun's magnetic field has a huge impact on life on Earth? Well, these solar currents are part of what makes that possible. When they reach Earth, they interact with our planet's own magnetic field, and this interaction creates electric currents in the ionosphere, Earth's upper atmosphere. These currents are responsible for a lot of the weird stuff that happens up there, like the northern lights and the ionospheric storms that can disrupt communications. But they also have an impact on the lower layers of the atmosphere too. Solar currents can drive winds that move heat and moisture around the planet. They also play a role in ocean currents. And while we don't know exactly how the solar currents interact with the Earth's systems, we do know that they're a major influence on our planet. Without these currents, our weather and climate would be very different. Like the Gulf Stream, a current that carries heat from the tropics to Europe, making the continent warmer than it should be given how far north it is. Or El Niño, a band of warm ocean water that disrupts weather patterns across the globe. Both of these phenomena are driven at least in part by solar currents. All this is to say that the sun's currents are a powerful force on our planet, but they're not the only one. Gravitational tugs from planets, moons, and even people affect these currents too. And all these forces combined create a complex web of interactions that determine where we are in the solar system. This is all happening on a scale that's hard for us to wrap our minds around. Like the sun's gravity is what keeps Earth in orbit around it. And Earth's gravity is what keeps the moon in orbit around us. The moon, in turn, affects Earth's tides. But the moon and Earth's gravity also have a small effect on the sun's currents. It's a tiny influence, but it's measurable. Scientists have actually detected changes in the sun's corona that correspond to the moon's phases. And that's because the moon is slightly tugging on the sun's corona and causing it to change shape. But it's not just the moon. Everything in the solar system is affecting the sun's currents in some way. Mars, Jupiter, Neptune, even Pluto. Each planet's gravity creates a small disturbance in the sun's corona. And when these disturbances line up, they create a giant wave that blasts around the solar system once a year. This wave is called a planetary wake, and it travels from the inner solar system out to Pluto and beyond. And as it moves, it affects everything in its path. We think that these wakes may be responsible for some of the weird stuff that happens on Mars. For example, there's a strange feature called the megascar. It's a giant gash that stretches for thousands of miles across the planet's surface. We think that it was caused by something called a megaslide, when a huge chunk of Mars's crust suddenly slips past another chunk. And while we don't know exactly what caused the megaslide, we suspect that it had something to do with the planet's rotation and the gravitational tugs of the other planets. Okay, so now we've gone full circle. We started with the sun, and we've talked about its magnetic field, its activity, its atmosphere, and the currents that flow from it. We've seen how these currents affect Earth and Mars, and we've learned that everything in the solar system from the moon to Pluto influences these currents in some way. But it's not just the stuff inside the solar system that affects our sun. There's also stuff out there that we can't see. Interstellar currents come from outside the solar system, and they're a constant source of energy for the sun. These currents are created by things like supernovas and other huge explosions of energy, and they carry stuff like dust and gas that can affect the sun's corona. We think that these interstellar currents may be responsible for some of the sun's activity. For example, when a particularly strong current hits the sun, it can trigger a solar flare or a coronal mass ejection. And those, as we said earlier, can cause auroras and geomagnetic storms here on Earth. One of the most exciting things about the sun is that it's constantly changing and evolving. As it goes through its cycles of activity, it affects everything in the solar system. And as the interstellar medium changes, new influences arrive from beyond our solar system. It's a reminder that we live in a dynamic and ever-changing universe. And while we've come a long way in understanding the sun, there's still so much we don't know. The sun is a reminder that there's always more to learn. So keep asking questions, keep exploring, and keep wondering about the incredible things that happen in our universe. Okay, thanks for watching. See you next time.